to our presenter, Andy Burgess.
Thanks, Ruth, for the introduction, and thanks everyone for waking up slightly before 9 to join this wonderful call about safeguarding your watercourse in regards to new regulations associated with changes to discharge to watercourse compliance limits, which is absolutely critical for those in the food, drink and milk industry. So, quick introduction for myself. As we said, Andy Burgess, I'm the sales leader for design, build, operation and maintenance of effluent treatment plants for Nijhuis. And we're going to go through 3 key areas today. What are these new effluent discharge limits that are currently being implemented? Why is this important for the food, drink and milk industry? And if this is an area of concern for yourselves, then what do you do? What is the pathway to compliance? To not only meeting a new consent change, but also safeguarding yourself for the future and taking into mind these new limits. So let's dive in and stay afloat for compliance. So first off, what are these new effluent discharge limits to watercourse and how did they come about? So something called the Best Available Techniques reference documents for the food, drink and milk industry. And these are European regulations that came about from the Industrial Emissions Directive, were put into place to reduce the pollution to the environment in terms of air, water and soil for the food, drink and milk industry. We might think, well, we're not in the EU anymore. Why is this important for us? But we'll talk about that on the next slide. But in terms of these best available techniques reference documents themselves, they have implemented best practice limits for the food, drink and milk industry that are discharging to watercourse associated with chemical oxygen demand, which is basically the sum of all pollutants that you are putting down the pipe in terms of effluent discharged, total suspended solids, which is the mass of solids in your effluent, and then total nitrogen and total phosphorus, which is, a vital nutrient for our ecosystem at the right levels. But if this exceeds a certain level, this can cause toxicity in our watercourses. So a major area. And the important thing is there that compared to historical consents in the UK, these are almost a factor of 10 lower than historical limits in discharge to watercourse. So absolute key and major changes that would need to be made to meet these new consent limits for the majority of effluent treatment plants from food, drink and milk industries in the UK. So that gives a quick summary of what these limits are and how they came about. But ultimately, why is that important for you? As I said, these were European limits. We're not in the EU anymore. The reason this is absolutely critical is because the Environment Agency, the environment regulator in the UK, is implementing these guidelines in UK EA permits for discharge to watercourse. So although it's an EU regulation, these are being implemented in the UK. And in some cases, we've learned with a number of our long-term partnerships that these are being implemented with sometimes only 4 to 6 weeks to meet these new limits for existing sites. And it seems to be working on a priority basis, i.e. they're focusing on the larger flow rates, but ultimately all new and variations to site permits, we're seeing these new consent limits being implemented. So that's one reason why it's absolutely critical for us in the UK, because these limits are being implemented now by the EA. But in terms of the actions that are required to meet these new regulations, sometimes in short timescales, is we've got to consider optimizing the existing assets as a first stage. Then we need to understand, how do we need to upgrade these assets? Can we look at partial upgrades, new treatment streams in certain stages, or do we need to allow for a complete replacement to meet these new limits? So we've talked about the what, we've talked about the why do we need to do it? Why is this important? And then we've understood high level, what is the potential actions that we need to do? And finally, what are the risks here if we are non-compliant? You know, the major risks here are enforcement action from the EA, fines, and potential removal of that permit to discharge if we're not meeting that new consent, or unsustainable OPEX costs to meet these new limits, leading you to tanker some or a proportion of your effluent away to meet these new limits. So we've talked about what it is, why this is important, and what are the risks. Ultimately, we've got new limits being implemented. We need to make changes to our site. And if we don't, this could result in enforcement action, fines, and potential tankering of effluent away, which is neither sustainable or financially viable. So now, if you're in a situation where you have already been implemented this new consent, or you'd like to safeguard your consent against future changes, or you're looking at a site expansion where your permit's going to change and you need to take into account these new parameters, what do you need to do? What are the key stages and steps you need in terms of a pathway to compliance? At Nijhuis, we have a structured approach with our resources for this pathway that we've already implemented for a number of our long-term partnerships. I'm going to go into each of these stages in more detail, but very high level, first stage is to understand we need to undertake the treatability testing and feasibility, high level, of looking at the potential options. A large proportion of this is data gathering. So it's starting to understand what is the COD, nitrogen, phosphorus, total suspended solids contribution from all of your process areas, not only end of pipe, but also in production, to see if we can remove any of these proportions before it results in the effluent treatment plant. Once we've firmed up that design basis, we then go to a front engineering design study phase where we put together high level and then detailed CapEx and OPEX options, taking into account asset optimization, upgrade, or a complete replacement. But we're selecting those technologies based on recommendations from the best available techniques, reference documents themselves, and our own experience. Then we're on to the project execution phase, working closely with the end user, the regulator, to ensure that we're mitigating all associated risks, not only with compliance, but with the usual challenges of a design and build process. Once the assets are implemented, then we're focusing on operation and maintenance, delivering industry asset management best practice, because you can design and build the best system on the best data, but without the right level of operation and maintenance expertise and support, you may be back in the same situation of non-compliance. Another critical step is that it's not just a start the process, but we've got to keep that compliance going and that asset performance up for the life of the asset. And then the final stage is optimization and continual improvement for those assets. So that's the high level overview of how we get from an existing site that is non-compliant or a site that is looking for an expansion or upgrade or change to their permit that would negate this process to happen. So going into these stages in a bit more detail, stage 1, data gathering. This is ultimately where we're understanding what is the feasibility for your site, to build that design basis, to understand what changes need to be made to your current asset base to be able to meet these new limits in terms of discharge to watercourse. Yes, we need to undertake detailed testing in terms of, this could be composite or diurnal sampling. This is basically a description of different ways to sample and different frequencies to build up the right level of data to ensure that the data is representative of all associated happenings in production. So ultimately, if you're a 24-hour process and you're taking samples, if your effluent is highly variable, then we need to be taking into account all of those changes. And that's the reason why this data gathering first stage is absolutely critical. Also, we need to map out all of the effluent water balance contributors upstream in production and quantify what is the COD, nitrogen, phosphorus, and total suspended solids contribution from each of those areas within the process. Because ultimately, yes, we can resolve those situations down at the effluent treatment plant, but if we can remove some of those contaminants upstream with changes to production or chemicals used within the process, then ultimately that is the first line of defense. So once we've got all of that data, we can then fix a design basis for the next stage where we look at technologies or ways to optimize the existing assets to make these changes. So stage 2, process optioneering. So this is where we've got a design basis, or we've got a flow and load survey completed where we've quantified what are the flows of the various effluent streams, what's their composition in terms of COD, total suspended solids, nitrogen, phosphorus, and then we can start to look at the potential technologies that could be implemented. A critical point of this is to understand for the different contaminants, what form are these contaminants in? Are they in the particulate form, i.e. in the solid form? Are they in the aqueous form or the liquid form? This will define what technology we select to remove these these contaminants. So as stipulated in the bested label technique reference documents, we've got, sorry, excuse me for 1 second. So, rightio, sorry for that quick break. Got a 2-year-old that's getting, quite excited and loud. So, where were we? Process optioneering. So once we have fractionated our effluent to understand the proportions of COD, nitrogen, phosphorus, total suspended solids, we understand the form that these contaminants are in. Then we can start to select the appropriate technology to remove these contaminants, be that primary physical treatment, aerobic or anaerobic treatment, as well as the final treatment steps in terms of clarification, phosphorus, and nitrogen removal. So once we've selected our high-level process options, we can then go into a more detailed front-end engineering and design phase. And the critical steps of this involve understanding the footprint constraints of the site. Are there any regulatory challenges associated with the site in terms of noise, air, odour, emissions that we need to take into account? Not only reviewing the existing permit, but starting to engage with the EA to understand what considerations we need to be aware of. Also, key elements out of this stage is understanding what is the CapEx and OpEx considerations that we need to make for this project to be viable. Because ultimately, we need to meet compliance, but we've also got to find a financially sustainable solution. So this is where it's absolutely critical to understand, can we utilize existing assets? Can we make better use of production to remove some of these contaminants, to negate the need for investment in certain areas? And we need to build that program, because ultimately we've seen some situations in the UK where these limits have been implemented in an extremely short turnaround time, meaning that there has to be a level of communication at that stage for ourselves to work with our end users to come up with a program to go back to the EA to say, yeah, you know, this is your request, this is what is achievable. So it's critical to develop that program at an early stage to ensure and set that expectation in terms of the potential turnaround times and implementation for meeting these new consent limits. And then we've now got to the point where we've built up the data. We've selected the potential processes and ways to optimize the existing assets, replace and upgrade. We've then done the detailed design and built up the CapEx and OpEx costs ready for implementation. We've now come to the construction phase, which goes into sort of around five key areas. One is the initiation of all partners involved in the project to deliver. We've got the planning stages. We've got execution, monitoring, project control, and closeout. Key things to bear in mind for this process is ensuring continuous and frequent stakeholder engagement and communication with all key components within the construction phase. Not only the people building the assets, not only the site owner, not only the regulator, but also the community and any other stakeholders that may be involved in the process. Because if we can have that right level of communication and planning with all stakeholders, it can mitigate any nasty surprises that can sometimes potentially arise. And if we've got that communication going, we can build that collaborative level of communication and peace of mind to ensure a successful project. And then this is the final stage, the longer term stage of compliance, which is we've implemented our solution. We've got the right design based on the right data, the right considerations, and we've implemented the solution, ensuring we are meeting all of the requirements of the supplier of the technology, the design and build, the site considerations, the regulator considerations, as well as the community around us as well. But if all of those stages have been implemented in line with industry best practice, unless we operate and maintain those assets in line with industry best practice, their design and the considerations required for that specific site, then we're not going to meet compliance. So the final and also one of the most vital steps is to ensure that the right operation and maintenance expertise is in place for those assets. And ultimately, number one is always health and safety. These assets need to be operated with the right health and safety culture and practices in place to ensure that everyone stays safe. We need to ensure that the right technical support is in place for the asset management team, because, you know, there's always challenges associated with sites, and without the right level of technical expertise to either preventatively troubleshoot those issues before they occur via trend monitoring, also needs to be in place if there is an unforeseen challenge that pops up. Also, when it comes to maintenance, we need to have a preventative approach. So we need to ensure that we've got an appropriate planned preventative maintenance schedule to ensure that mechanically these assets are operating in line with industry best practice. We need to have close compliance monitoring routinely, not only on site, but also off-site UCAS accredited, to ensure that we have that chain of custody and evidence to provide to the regulator that we are compliant. But also, we need to not only ensure that we're meeting compliance, but we also need to understand how we can optimize, how we can innovate, how we can continually improve the process. And that's why once we've got a design and we're meeting consent consistently, and we're compliant, we need to be thinking, right, how can we optimize this process now we're meeting these new limits? That might mean optimizing chemical reduction, reducing sludge production, looking at options to reduce energy consumption. And these are all parts of what we call value generation in the Nijhuis operation and maintenance team. And it's all about that long-term partnership to not only deliver compliance, but also deliver long-term value. So that is the final stage, which brings us to the end of the sequence of stages to take us to compliance. Before I finally summarize what we've talked about and welcome questions at that point, I just wanted to kind of educate everyone listening and watching on NSI UK or Nijhuis or Industries UK, the company that I'm a part of, just to understand our resources in place to deliver the stages of these sort of action plans and implementations that we've talked about so far in the presentation. In terms of the upfront feasibility stage, we have in-house UCAS and treatability testing laboratories and a dedicated scientific services team for a flow and load survey in your production area and effluent treatment to build up that data to be able to select the process options to take on to the next stage. We have 75 full-time equivalent UK-based engineers, mechanical, electrical, civil, and process. This is the team that is delivering on the stages associated with the front-end engineering and design, and the principal project managers and principal development engineers for the design and build process, for which we have 185 references in the UK, as you can see, spread from north to south, east to west. We also have a in-house technology portfolio to deliver on process water effluent treatment that is unbiased, and we are focused on being able to provide the technology that is fit for purpose, not that is our core technology. We provide the technology from our portfolio that is fit for purpose, fit for the solution. That is the critical point. And then the final stage is our O&M solutions, or operation and maintenance outsourcing team, for which we have around 250 full-time equivalent operators, maintainers, territory management teams, maintenance support, asset care, and for which we have 25 large-scale references throughout the UK. So that kind of gives you a flavour of the resources that we have available to us to support you on your pathway to compliance. And then finally, we're going to go through a quick summary of what we've talked about. So what were we talking about? We were talking about new effluent discharge limits to watercourse that are currently being implemented for the food, drink and milk industry, which affects sites with a historical discharge that are being implemented with a change notice. This is affecting sites who are looking at an expansion or new build. They have to be aware of these new limits to take into account when they are designing and building their effluent treatment plant assets. Why is this so important? Because the Environment Agency is implementing these European regulations within short time scales that need implementing, which is having major implications on the ability for a food, drink and milk industry site to discharge, and in some cases resulting in unsustainable tankering costs and short-term remedial actions. So it's best to work for the future and start thinking about this now and come up with a plan on how you can meet these new limits. And then finally, we've gone through the key stages to bring your existing plant to compliance. Gather the data, understand the different forms of the new limits and contaminants that you're looking at. Process optioneer the solution in the right way with the lowest total cost of operation and carbon footprint to implement the technology and achieve these limits via the front-end engineering design study phase. Then we've got the construction phase to implement the technology, making sure that we've got close communication with all stakeholders involved, those being the supplier of the technology, the design and build implementation team, the site, the regulator, and any considerations that need to be made for the community. Then we've got that final critical stage, which is the longest stage, which is the operation and maintenance and continual compliance and optimization of these assets over the life of the asset, typically 10 to 15 years. So that's all I had for today. I hope you really enjoyed it. Thanks for starting work an hour early and listening to me for 20 to 30 minutes. It's been a pleasure. And yeah, please, if you've got any questions, concerns, immediate needs for a pathway to compliance, and you'd like to understand how we can resolve some potential challenges for you here, then please don't hesitate to reach out. And yeah, look forward to your questions. Contact at any point. So yeah, thanks, Ruth.
No problem, Andy. This is probably a stupid question, Andy, but the BAT emissions, the minimum emissions, what size facility do they relate to? So if you were a smaller brewer or distiller or dairy manufacturer, what size facility needs to be looking at this?
Size is not a factor. Yeah, it will be, as long as you're discharging to watercourse, then this applies to you. It's as simple as that. Size does not come into it.
So even the smallest of facilities will need to know what format their discharge is taking.
Yes, exactly. Yeah.
Okay, thank you for that.
I will maybe just add one point to that. In terms of the historical sites who are discharging to watercourse now, there has been potentially a priority for the Environment Agency to prioritise their action on the larger sites. But what we are starting to see now is that that priority basis is starting to come down to the smaller sites. So I definitely have evidence of these limits being implemented for smaller sites.
Thank you. I can't see any other questions in the group chat, Andy, for now. So maybe people are, if they think of something they'd like to talk to Andy about, please do contact him direct. We will put his contact details in the email when we send it to you. But other than that, just for me to say, have a good day and thank you for joining us.